Okay, so today we're actually going to start by talking about electricity and magnetism. So what we have right here is electrical force, and electrical force is basically that attraction or repulsion of two items that have electrical charges. So let's talk about this. So let's take a generic object. Let's say a balloon. A balloon basically can just sit there and it doesn't stick to the wall, doesn't stick to your hair. But if you take a blown up balloon and rub it in your hair will actually rise up and attract to it. So what's happening is protons are staying in the object, but you are either gaining or losing those electrons. An object, if by just sitting on the table, is neutral. That means its protons and electrons are the same. They're equal. Okay, but as I said, take that balloon and you actually charge it up, you rub it, or take the activity with the can. By rubbing the can, you can get it to actually move, and that's showing attraction or repulsion. When an object loses electrons, that object will become positively charged. Let's say inside the nucleus you have 6 protons, and outside you have 6 electrons floating outside. What happens is when you rub it, you're going to rub off those electrons, so you have fewer electrons than the protons that are inside. If you take an object and you rub it and it actually becomes negatively charged, that means you're actually rubbing on electrons. So that's how an object gains or loses. It's the electron, that particle, that is electricity. Alright, so here we have static electricity. You can see this little girl right here. She's touching this ball. This is called a Van de Graaff generator. We have one at the school, but it's currently not working. So once we can get it working, we'll bring it out and we can play with it. But what it does is it builds up the charge. Look at the man with the balloons right here. He is building up the charges, and an object will actually stick or attract to it. There are 3 ways you can actually transfer those electrons. One way is friction by just rubbing the object. Another one is conduction by actually touching. Think of the winter time. You're rubbing your feet on the carpet. You go to a door handle that's metal. You touch it. Bam! You get shocked. Induction means, have you ever been out there, rubbed your feet on a carpet, get very close to the carpet or very close to a door handle, not touching it, and it actually shocks you? That's induction, where the charges actually jump from one object to another. Okay? Now, as I said, let's look more in depth at those 3 methods of charging objects. So again, friction, you're rubbing those objects. An example would be rubbing a balloon with the hair. The other one is conduction, where you're charging it by touching. You're actually touching an object and you're transferring the charges build up on you to that object. So a negatively charged object touches a neutral charged object, and then therefore that object becomes negative. You're transferring the negative charges. Induction is that last one, again, transfer of a charge without even touching that object. So a neutral doorknob and a negatively charged hand, your hand, you go by, you get close to the door handle to touch it, bam, you get shocked, or you feel the shock of the charges from you going to that door handle. Okay? Now, materials. In order for electricity to flow, or these electrons to flow, there are certain materials that allow it to flow, and then there are certain materials that do not allow it to flow. If the material does allow it to flow and move, then they are called conductors. And basically that is any type of metal. Your copper, silver, any kind of metal like aluminum. Copper is the main type of wire that's found in any of the electrical wiring components in your home, on appliances. Then we have something called an insulator, and an insulator is basically those materials that stop it or resist those electrons from flowing. An example of that would be wood, And also think about your insulators, like your coolers. Coolers are made up of rubber or plastic materials, and they don't allow electricity to flow through. Later, we're going to find out they don't allow heat as well to flow through. Your wire down here has a rubber insulator around it, and the reason for that, if we didn't have it, that wire would heat up, get really hot, and electricity will flow from one object to another, and that's how people get shocked. Okay? Now, a current. Current basically is that flow of electrons in a single direction. Current is how those electrons flow. There are two types of currents that are out there. We have direct current and alternating current, otherwise known as AC and DC. Your DC are your basic ones, that's your batteries, A, AA, AAA, C, and D batteries, even the 6-volt batteries. Basically, it will flow in one direction, okay? And the alternating current are like your outlets in the wall. There are two prongs in there. Electricity can flow on either way, in and out. There's an outlet there, okay? Now, current, again, as I said, is that flow of electricity or electrons through a wire. The unit that we measure current in is called an amp or an ampere. Okay? Resistance is that resistance to stop or slow down that flow of electricity. Resistors are placed in wires to actually prevent it from overheating or causing a lamp to go out. And they're very important. Resistors are extremely important in wiring your house. There's another thing called a circuit breaker or fuses, and they also do the same thing as a resistor in that they stop or slow down the flow of electricity. The unit that we measure it in is an ohm, and this is the symbol for it, is the omega symbol that we have right there. The last one is voltage, and voltage is also identified as potential difference. Voltage or potential difference is basically that push or that force that's going to allow those electrons to travel through the wire. Okay, so the unit for this one, very easy to remember. For voltage, it's actually a volt. Okay, now if I have a wire, okay, and I want the electrons to travel through it, there are things that affect how electrons flow through that wire. These are things that create high or low resistance. So let's say the length of a wire. If I have a very long wire, that electrons have to travel a long distance. It's sort of like, do I want to go from South Central to the mall in Greenville, or would I like to get in my car and go all the way to Raleigh? Going to Raleigh, that's a long trip, so it takes a long time. The shorter wires actually have lower resistance. It can get to that point very quick, very abrupt. Thickness of wire is also important. Think of this. Traveling down a two-lane highway. You're going in one direction. The car is passing you going in the opposite direction. If it's 5 o'clock traffic, you're going to sit there at the light or at the stoplight down there at Reedy Branch Road, and you're going to wait for the traffic to actually pass by. But if we opened up more lanes, made it wider, then the electrons will actually have more pass to actually flow through. Think of it also, have you been in a big city where you have multiple lanes? It helps open up that traffic flow. Temperature is another one. Oops, let me come back to that. Temperature is another one. Temperature, basically, hotter temperatures, believe it or not, prevent electrons from flowing. Electrons like it cold. They like it cool. So the cooler the temperature, the easier it is to flow. The hotter the temperature, the higher the resistance, or the more ability to allow it to stop. The last one is composition. If you have insulators, that's going to prevent it from flowing. And the last one, if you have conductors, which are metals, the electrons are actually going to flow very well. Okay? We'll end on this one. This is Ohm's law. These are the ways to calculate your amount of voltage, your amount of current or amps, and also resistance to see how much current electricity is actually flowing through a particular setup. Okay, so the formula for this is the volts, V, is equal to I times R. I represents your current. So amps times ohms equals your voltage. And see, this voltage is on top. So I will end here for today, and tomorrow we'll continue by calculating the formulas for Ohm's law and power. Thank you.